Hello all. So today we are going to start the last new topic that we will work on this year in Applied Algebra 1. Congratulations guys, if you can make it through the next 4 video lessons, you have completed Applied Algebra 1. Now we will be doing some review for the entire year in the month of June. But as for new topics, this is the last one. Okay, so let's jump right into this. Today we're going to talk about graphing quadratic linear systems. Now we have graphed systems before. Remember, this is where you would graph like 2 lines, and then you would shade an area or find an intersection point, and that would be your solution. So we've graphed these before, and when you see one, you'll completely and utterly recognize exactly what I'm talking about. But for now, let's talk about some things really quickly. When we graph systems, we are either looking for a solution point, which is where 2 lines intersect, or a solution set, which is where 2 inequality lines intersect. Remember, we would shade areas. When we graph quadratic linear systems, we are looking for solution points. And the distinction here is the S. So this S changes everything. It means that instead of having a single point or a shaded area, we're going to have more than one solution point. There will be one of 3 possibilities when graphing quadratic linear systems. There are 2 solution points. There is 1 solution point, or there are no solution points. And once you see one of these done in front of you, you will instantly understand the difference between these 3. So let's try graphing a quadratic linear system to see this in action. Okay, I'm going to reveal my graphing calculator because we will have to use a graphing calculator to help us graph one of the quadratic equations that we're going to draw. Okay, so I'm going to scroll down a little bit. So this is a quadratic equation. Remember, quadratics are in the form ax squared plus bx plus c. Now remember, in order to fill out this table, I can make it very easy on myself by using the graphing calculator. So all I have to do is go to the y equals button and press that. Then I'm going to press the xt theta n button and square that. I'm going to subtract an xt theta n, and then I'm going to subtract 6. And here you can see that I have input the quadratic equation into the y equals section. Now if I hit the graph button, it'll draw a picture of what that quadratic should look like. And then if I press second graph, I can see a table. So remember, I'm trying to fill in from positive 3 to negative 3. So here you can see that when x equals 3, y equals 0. Oh, I'm going to switch my color back to black here. When x equals 2, y equals negative 4. You can see that here. When x equals 2, y equals negative 4. When x equals 1, y equals negative 6. When x equals 0, y equals negative 6. When x equals negative 1, y equals negative 4. When x equals negative 2, y equals 0. And when x equals negative 3, y equals 6. So now all I have to do is graph these points on my graph. So first, the point 3, 0, right here. I'm going to graph that first. So 3, 0, it means I'm going to go to the right 3 and then stay on the x-axis because my y is 0. My next point is 2, negative 4. So I'm going to go over 2 and then down 4. My next point is 1, negative 6. So I'm going to go over to 1 and down to negative 6. My next point is 0, negative 6. So I'm going to stay at the origin. Whoops. I'm going to stay at the origin and go down to negative 6. My next point is negative 1, negative 4. So I'm going to go to the negative 1 and down to negative 4. My next point is negative 2, 0. So I'm going to go to the negative 2 and stay on the x-axis because my y is 0. And here you can start to see the U-shape. I don't really need to graph this point. Negative 3, 6. I'm going to graph it anyway. I'm going to go to the negative 3, and I'm going to go up 6. Now, I can estimate that my other point is going to be about here. I'm guessing. And if you look at the picture, that seems about right. So I'm going to go ahead and draw this parabola as best I can. Okay, so there's the parabola graphed. Now, I'm also going to draw a linear line. Okay, remember that linear lines are in the form y equals mx plus b. And we've worked with plenty of those in the past. Now, if you, find it easier to use the y equals button, we're going to clear out that old equation, and let's put in this one, 3 xt theta n for an x minus 6. Now I can graph that line, and it's going to look like a straight line. But I can also look at the table by pressing second graph. And once again, I can see that when x equals 3, y equals 3. When x equals 2, y equals 0. When x equals 1, y equals negative 3. When x equals 0, y equals negative 6. When x equals negative 1, y equals negative 9. When x equals negative 2, my y equals negative 12. And when x equals negative 3, my y equals negative 15. Now, I can go through and graph these points if I want. But remember, there's an easy way to graph straight lines. Remember that my y-intercept is the point on the graph where the line crosses the y-axis. So if I look at this B, this y-intercept, I know I need to put a point. I'm going to change my color here so it's easier to see. I know I need to put my y-intercept for my linear line right there on negative 6. And then my slope is right here. And I know my slope is 3 over 1. So I'm going to go up 3 and over 1. I'm going to go up 3 and over 1 again, and again, and again. As a matter of fact, I can go over 1 and down 3 to continue the pattern. and I'll go up 3 and over 1 more time to continue there. Okay, so now all I have to do is draw the straight line through the dots. I'm drawing on my computer, so please forgive me for the wonky squiggly line. But you can see here that there's a point of intersection right there and a point of intersection right there. And guess what, guys? Those are my solution points. So this point here, which I can write as a point, so that would be 3, because I'm going over 3. Oh, excuse me, 4, my bad. Let me erase that. It's a 4, and I'm going up how many? 6. So the point 4, 6 is a solution point. And this point down here, which I can write as 0 because I'm staying on the y-axis, and then I'm going down -6. That point is also a solution point. Okay, so that is how you solve one of these problems, okay? Now, normally if you were taking a paper test, there would be a spot where you could write the solution points down here, and you would do a parentheses with your numbers. You'd write solution point again, and you would do a parenthesis with the numbers. Okay, but other than that, guys, this is really it. This is the last new topic that we're going to cover. I think this is relatively simple since we've done things like this before in the past, okay? But keep your eyes open for a bell ringer and a homework assignment associated with this lesson. And as always, guys, stay safe.